podcast, we're going to talk about resonance. All right, resonance is when you can have more than one valid structure, Lewis structure, for a molecule or an ion. NO3 is a good example. So let's sketch it real quick. All right, so N has 5 valence electrons. And then O has 6, and then there's 3 of them, so that's 18. And then we got this one extra electron that we're going to be able to add in. So that's another one. So we've got, let's see, that'd be 23, 24. So we have 24 total electrons here. Okay. All right. And then we have N or Br central, and then it'll bond to each of the O's. Okay. All right. And let's see, that gives us, that used 6 of those. Okay. So we have 18 left. All right. So let's start giving them to oxygen here. Okay, so that gives this one 8. All right, let's go ahead and get nitrogen, 8. All right, there's 8. So we have that used 8 more electrons. So we have 10 left. All right, there's 6 more, so we have 4 left. All right, now there's all our electrons. We've used all of our electrons. Now let's count. So we have 2, 4, 6, 8 on this oxygen, so he's satisfied. 2, 4, 6, 8 on this one, so that one's satisfied. Nitrogen has 2, 4, 6, 8, so he's satisfied. But this oxygen only has 2, 4, 6, so he's not satisfied. So we need to move this lone pair over here, and that gives us our double bond. Okay, so there is the structure. Okay, but you could have drawn it like this. Okay, so we could have drawn it like that with the double bond on this side, or we could have drawn it like this. Okay, so basically the moral of the story is we have no way of knowing where that bond is. Okay, so to indicate that, we use these little symbols in between. Okay, it's a double arrow, double-headed arrow. Goes like that. Okay, so that indicates that there are resonance. This is resonant structures. These are all the same structures, but they're just modeled in a different way. All are valid. However, when we do spectroscopic studies and all kinds of studies on these molecules, we find out that it's actually not any of these cases. Actually, what you end up having is you have an average between all of these. Okay, so double bonds are smaller than single bonds because they share more pairs, so they have to be closer together, so they're shorter. And what we find is that when we actually look at an NO3 molecule, the distance between N and O is actually not the length of a single or a double bond. It's actually a mix of the two. So it's an average of all of the structures. All right, here's another example of resonance with more than one valid structure. We see benzene. Okay, benzene is this ring right here. We have double bonds and we have single bonds in the ring. So we don't know if the double bond occurs here or here, as you see. So we show this with our double-headed arrow. And then when we look at the bond links between these, we would expect that the double bonds would be shorter because they're sharing more pairs, and so the atoms should be closer together than these single bonds. But what we actually see is that all of the bond links in the ring are identical, which means that it actually is an average of the two. Okay? So it doesn't switch between the two, it's an average of them. So all the bond links are identical. Bond links that are resonant are shorter, as we've just seen in the past 2 examples, because they're kind of like a hybrid of 2 bonds. Okay, so in this one, here's benzene again, we see that the bond links are actually going to be about a 1.5 bond. Okay, so they are a little bit longer than a double bond, a little bit shorter than a single, but they are a little stronger than a single and a little weaker than a double. So they're in between the two. Okay, here's another example, ozone, O3. Okay, so we see that we have a double bond and a single bond on our O's, and we see actually, again, it's in between. All right, and here are two other examples. We have carbonate ion, which is CO3 minus. So you see that we don't really know where the double bond is. And then we have an acetate ion, okay? Again, double bond, we don't know if it occurs on the top or the bottom oxygen. Okay, so it's all going to be a mixture of all of them. Okay, now let's go back to ozone for a second, because sometimes you will see resonance drawn instead of drawing two structures. Sometimes what you see is something more like this. Okay, so we've got our ozone molecule. We're going to go ahead and add our electrons, but instead of indicating two different structures with double bonds on each side, sometimes you'll see these little dashes. They indicate that this is a resonance structure and that it's an average. So these kind of count as like half bonds. So instead of this being a single bond, it's like a bond and a half. It's between a double and a single bond. So you'll see that drawn as well. All right, and that's resonance.